Hey everybody, this lesson is going to be a pretty direct one. We're just going to really get to the nitty-gritty of the distance formula. So you actually have two different distance formulas. One distance formula is strictly for distance in one-dimensional space. What do I mean by that? Well, if I asked you, how far apart are the numbers 5 and 8? When you're asked a question like that, you are finding distance. So the title of the lesson is on top scrolling, distance formula. So make sure you write that down too. If these are on a number line and you want to know how far apart they are, a lot of people might count 6, 7, 8, 3. Sure. Others of you, sorry about the blurriness, others might use a mathematical operation. You're going to use subtraction. So you might go ahead and do 8 minus 5 equals 3. And that is truly distance. However, what if instead of asking you how far is 8 from 5? What if I had asked you, so this is example 1. What if I had asked you how far is x from y? What you need to notice in this situation is we don't know which number is bigger, x or y. So how do I know I'm doing 8 minus 5 and I'm not doing 5 minus 8, right? So in the case like this, if you were like, oh, then I'm just going to do the same thing, x minus y, but what if you find out that y is bigger? Got you covered. The real formula is you could take either one and subtract them, as long as you put in some safety precautions so you don't get a negative distance. What safety precautions am I talking about? Well, absolute value, of course. So this is really our formula for distance in one-dimensional space. You can use that, or you could turn it around and use that right there. Either one is acceptable. But what you are probably thinking of when you hear distance formula is that, well, there's distance equals rate times time. That's not the distance we're talking about. I always used to remember it looks like the word dirt if you did this, so you can remember the formula. That's still not the one I'm talking about. I'm talking about this big distance that uses a big square root. Do you know what I'm talking about? And a lot of people get confused and don't remember what it is, and they're like, oh, poor me. Well, what if I told you that the distance formula and the Pythagorean Theorem, they're really the same thing? Maybe you could remember then. Let's see. So let's say you have a point on your plane and you have another point on your plane. This point I'm going to call x sub 1, comma, y sub 1. This point I'm going to call x sub 2, comma, y sub 2. And I want to figure out how far apart these 2 points are. They aren't on a number line anymore, so I can't just count the boxes. That is not going to work. What we do is we can drop a side down like that, and we could draw out a side like that, and we can make a right triangle. We could also then figure out this ordered pair and bust out some Pythagorean theorem. So what we're doing is, where does distance formula come from? We could think of it this way for now. Now, what came first, the chicken or the egg? What came first, distance formula or Pythagorean theorem? We'll talk about that in the future. Where does distance formula come from? I mean, they're really one and the same. They're also equation of a circle, but let's heavy chalk. We're not going there yet. So what would this ordered pair be? If the origin, we don't know where the origin is right now. It doesn't really matter. What if it's here? You went over x up y. Went over x sub 2 up y sub 2. So this coordinate is x sub 2, because it's right underneath the other x, but I only go up how much? Y sub 1. Okay, got it. X shows us the values in this direction. Y shows us the values in this direction. Again, this triangle could be flipped sideways, whatever, all different ways. So how long is this side? And how long is this side? To figure out how long this side is, we're going to do our one-dimensional distance formula. We're going to subtract these two guys right over here, and I'm going to do x sub 2 minus x sub 1, but like I really don't know if x sub 2 is bigger or smaller. So you could put it in absolute value bars. Just stay with me here. We leave it like that because we don't have numbers to plug in yet. Here, on the other hand, how far apart are these two dots? How long is this side of the triangle? Same idea, except it's the change in y. Kind of like slope, right? Here's rise, here's run, but it's sort of turned the other way. Don't confuse yourself. I'm going to do y2 minus y1, and again, I'm going to put it on those absolute value bars. We know that makes any number, we're just looking at its like magnitude or its positive value, how far it is from 0. Yes, you could turn it around and subtract the other way, yada, yada, yada. Now, what if I told you I'm going to call this side A, I'm going to call this side B, and this side, normally we call it C. A squared plus B squared equals C squared is our Pythagorean theorem. Good old Pythags, right? Oof, that's bold. Now, let's not call it C, let's call it D. D is for distance. Does it matter what letter you call it? No, so relax. All that matters is the two being added over here have to be the legs. And we're good. Now let's fill in what we found our legs to be. Sorry, a little squashed. All right, x sub 2 minus x sub 1 and y sub 2 minus y sub 1. When you square something, squared, second power, you're multiplying it by itself. So it's either a negative number times a negative or it's a positive times a positive. Either case, what kind of answer do you get? Well, a negative times a negative and a positive times a positive are both positive. So we can really ditch the absolute value bars. Not necessary. Make sure you do PEMDAS. So far we're there. But I'm trying to solve for D, distance. What's the inverse operation of a square? A square root. I'm going to take the square root of both sides. Here's one. Here's another. I'm also going to flip this over. I'm going to put D in front. So D for distance, or the length of that side, how far those points are from each other, equals dun, 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 x2 minus x1. Subtraction gets you one-dimensional distance squared plus y2 minus y1 squared. So a lot of times people forget like where the plus and minus signs go. But if you remember that these are minus on the inside because they got you the lengths of the sides of the triangle, and they're plus in the middle because it's coming from the Pythagorean theorem. A squared, B squared equals C squared, which is D squared, and we took the square root. Bam. Then you'll never get confused about the distance formula. So definitely should know this by heart. And the more you can make connections with where things come from and how they relate to other things that you've learned, the more likely you are to remember it in the future. So when you are applying distance formula on the examples today, we want to make sure we follow PEMDAS rules, positive and negative rules, squaring rules, combine like terms, and we want to make sure that when we get a radical, we simplify completely. Okay? So let's move on to some practice. We have a worksheet, and I'm going to help you get started. Find the distance between each pair of points. Round your answer to the nearest tenth if necessary. Cross that out, and let's put simplify. We're not rounding. We're more sophisticated than that. We will have precise answers with radicals. So over here, first thing, I'm going to write down my ordered pairs. -5, 5. And that is over 1 down 2. Assign x1, y1, and x2, y2 if you'd like. Pretty helpful. And then let the magic begin. The first thing you should do for every example is write down the distance formula. Don't try to be a hero. We're all learning here. We got to get better and better. So distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Also make sure the roof goes all the way over till the end. And then we fill in. In this case, it's 1 minus negative 5 becomes plus 5 squared plus y2 minus y1, so go in the same order, negative 2 take away 5 squared. Next step, d equals, don't forget the left side of the equal sign. 6 squared plus, when you have a negative, you want to keep those parentheses around. Distance equals, you should know your squares by heart, 36 plus negative and negative, 49. Distance equals 30 plus 40 is 70. 6 plus 9 is 15. So this is the square root of 85. Remember, we said simplify if necessary. 85 is 5 times 17, and it's not cannot be simplified, not simplifiable. So you're done. The distance is square root of 85 units, and there's nothing else you can do. But if in the next example you can continue with more, then go right ahead and do that. So you got a lot of examples here. Sometimes you might end up with a 0 in the equation, and that's okay, here and here. No big deal, but you could find the distance just by counting boxes if it's one-dimensional. That means left, right, or up, down. The way you would recognize one-dimensional distance over here is like, see number 12? They both have a y of negative 10. Try plotting them first. You don't have to plot these, but if you do, it might help you recognize these cases like that. Another thing you can do, if you are a visual person, is you can draw the triangle, count the boxes, and just do Pythagorean Theorem. D squared equals, I'm just turning it around, 5 squared plus 5 squared, and finish from there. If you continue from there, take the square root, I promise you this radical can be simplified. So make sure you take care of that. So there's plenty of examples for you to try. So do your best to get as many done as you can, all right? You wanna make sure you do a couple of each type, graphs and without graphs, and try the different strategies. If you think you can do this and feel pretty confident, then give the video a thumbs up. And if you think you're gonna stink it up and need more support, put a thumbs down. See you later.